Hello, and welcome to the first of our quick chats that we're holding for Laser Focus World's PhotonicsNEXT event. I'm John Wallace, Senior Editor at Laser Focus World, and I'm speaking with Mark Zediker, founder and chairman of Nubra, the company that produces a line of high-power blue lasers for materials processing and 3D printing. So Mark, let me start by asking you if you could say a bit about Nubra, how it came about, and what the company does.
Great. So as I told you earlier in our conversation, I've been involved in laser diodes for many years. And I was watching this technology for quite some time and said, this looks like an interesting application, an interesting technology. If it reaches enough power level one day, we could transition this to an industrial process. And so as a consequence, we saw the power levels rising up. We were able to raise some funding and get the company off the ground. And as a consequence, we've been really developing what we consider groundbreaking technology in the blue laser area. And this is a new class of high power, high brightness lasers, which will dramatically improve speed and quality of metal processing, in particular copper, where the absorption characteristics are very high, and golds. But it also does a great job with the stainless, the Inconels, and all the other standard materials people like to use. In addition to that, we focused pretty hard on additive manufacturing as well, trying to understand what can the blue laser technology do to improve that as well. And we've discovered that it can indeed print faster than you can with an IR laser, with less defects. And in fact, in some of our applications we've tested, we've seen speeds and density improvements up to better than 9x over what the IR laser is. So it's a very exciting new technology that we've been exploring what it can do over the last couple of years.
And the technology is based on blue diode lasers.
Yes, that is correct. In fact, Nubra uses the blue diode laser chips, gallium nitride. And because we're using chips, we're able to align these things individually to their optic assemblies. And so we can optimize the brightness of the system. Depending upon how we configure the system, we can achieve greater brightnesses than could be achieved with a bar-based technology or with some of the other more conventional IR technologies that are out there.
So the big question is why use a blue laser for materials processing and 3D printing when there are, IR lasers everywhere? Why use blue?
Great question. So there are multiple things in physics which favor the blue technology. And the first aspect of it is the absorptivity of materials. Virtually every material out there absorbs greater as you go to shorter wavelengths. And for example, in the infrared, when you hit copper with an IR laser, you have about a 5% absorption characteristic. In some of the IR ring technology, they preheat the copper to double that to maybe 10%. Blue starts out with a 65% absorption on the surface from the start. So the start of the weld is quicker. The ability to create spatter-free welds is near ideal, and the ability in additive manufacturing to create highly fully dense parts is also something that we've been able to achieve. So first you have that physics advantage. The second physics advantage you have has to deal with some advanced technology we've been developing where we take advantage of the short wavelength. And because of the short wavelength in additive manufacturing, we'll be able to build parts that are larger with higher resolution and at higher speeds than what can be done today. So blue has a lot of advantages just from the physics of absorptivity of materials with shorter wavelengths.
And blue has, compared to green, I think, how does blue compare to green? I think isn't it better than green?
So of course, the blue and the green are very close in wavelength, about 100 nanometers apart. The blue has an advantage in all materials over the green. They're within about 10 or 15% of each other. But the real key is the technology. The technology to make a blue laser is very simple compared to the technology to make a high-powered green laser. As a consequence, the reliability, the cost, and the performance is going to be better on the blue laser technology side than on the green laser technology side. For example, a 1 kilowatt green laser, if you've ever seen Trump's green laser, is quite large. A 1 kilowatt blue laser literally fits into a 19-inch rack. So The advantages are that it's going to be more compact, much simpler to build, and as a consequence, more reliable long-term.
I know that there are other companies producing blue lasers, and I think maybe high power blue lasers. What sets you apart from these other companies?
Another great question. And well, again, as I mentioned earlier, what we focus on is using the individual chips, not bar technology. So because of the individual chips, we can place them in any configuration we like to preserve all of the brightness of the laser source. Now that brightness is important when you're trying to do material processing or additive manufacturing. Our nearest competitor uses a bar-based technology, and that bar-based technology has a fundamental limitation in how much brightness it can actually produce. So as a consequence, we can create a higher power, higher brightness source than you can with the bar. Now, to take that one step further, we've been developing an advanced technology, which is a single mode blue laser that goes well beyond anything that's out there today. Neither the green lasers or the blue lasers are able to achieve that kind of beam brightness. And because of that, we believe this is going to be a very disruptive technology for the additive manufacturing segment.
And the advantages of a very high brightness blue laser for materials processing, I think are pretty obvious, but if you could go into them just a little bit.
Absolutely. So everybody would like to do keyhole welding when they're doing the welding applications. And in particular, everyone's interested in doing it remotely. So with a blue laser, the wavelength required to create a spot is the spot is proportional to the wavelength and the focal length of the lens. So if you, for a given lens that you have in the infrared, you can actually have twice the throw distance or twice the remote welding distance that you have compared to an infrared laser. In terms of a green laser, there is no single mode green laser high power, so it cannot compete in that brightness structure at all. So the big advantage to going to the super high brightness, which is single mode technology, is we now enable a whole new range of applications ranging from additive manufacturing in large volumes to additive manufacturing in very small volumes, such as MEMS devices. It will now be possible to print things with sub-micron features.
Tell me a little more about your presence in the electric automotive vehicle space.
Sure.
I know that they use a lot of copper for the batteries.
Great question. And in fact, we've focused very, very heavily on, how do we optimize some of the welding technologies out there for electric vehicle manufacturing. And one of the first areas that we discovered that we could do a great job in is actually welding foils, large stacks of foils, defect-free. That's something that had not been accomplished before. And in fact, had been being done pretty much with ultrasonic welding up until now. In addition to that, we've done a lot of testing of being able to weld bus bars and all the other infrastructure components of the electric vehicles. So we really believe we have a foundational technology that will allow electric vehicles to have smaller weld beads, will be able to be produced at higher speeds, and will be able to produce with virtually no spatter. As a consequence, much higher reliability in the battery cells and in the infrastructure or construct of the battery cell itself.
We have just a couple of minutes, but maybe you could talk a little bit about 3D printing also.
That has absolutely been one of my favorite topics for quite some time. And what we've done at Nubra is a couple different things. We've actually done some area printing technology where we are able to print a area of a pattern, kind of similar to carbon 3D, but in metal using blue lasers. And we've also been able to demonstrate very high print quality using blown powder technology with some of our partner companies out there. And we are right now getting ready to do some tests in a powder bed system to see how much we can improve its capabilities as well. But the bottom line is we'll bring higher speeds, better densification of high reflectivity materials to the additive manufacturing market where they struggle today and have to use very high power lasers. We'll be able to use a low power laser to do what the high power lasers can do.
And my last question is, do you have any closing remarks you'd like to make?
Well, I really appreciate you taking the time to talk with us today. Nubra has been an exciting adventure. We have a fabulous team, tremendous amount of experience at our manufacturing level and in our operations level, as well as our management team. We've installed automated manufacturing capabilities to give us that leg up as we bring these products to the market. So Nubra is well positioned to be the supplier of the future.
Okay, well, on behalf of Laser Focus World, I'd like to thank our quick chat guest, Mark Zedeker of Nubra, for joining us at the Photonics Next event to fill us in on high-power blue lasers and their advantages in materials processing and clearly 3D printing.
Thank you, John.